Hello and welcome to Teaching Python. This is episode 136, and today we're going to talk about learning Python with Dr. Chuck. My name's Sean Tiber. I'm a coder who teaches.
And my name's Kelly Schuster-Paredes, and I'm a teacher who codes.
Welcome, Dr. Chuck, to the show. We're happy to have you.
And I'm Dr. Chuck, and I am a teacher, and I'm a coder.
Oh,
Very
you got
nice.
them both.
Very nice. Well, we're excited to have you this week. We're going to talk about learning and MOOCs and possibly race cars and all kinds of fun stuff. So we're excited to get into that conversation, and we'll do a little bit longer introduction for the three people who haven't learned Python from Dr. Chuck at this point in a few minutes. But let's start with the wins of the week. Dr. Chuck, would you like to go first?
Well, this week I got back from vacation in Portugal. It was one of those throw a dart at a map vacation. And the way we threw the dart at the map is my wife follows an influencer. And we figured out the rough area where she lives. And without intending to find this person, we just wanted to experience the things that she did. And so we reenacted going to certain coffee shops, going to certain stores, eating at certain restaurants, and kind of experiencing this influencer's life. And the good news is it was really throwing a dart. But we ended up in the Algarve in Portugal, which is like Europe's beach. And it's very tourist friendly. And there's a million things to do. And we just had a great time. And we inadvertently showed up 1 week before school was out. So it was all ready for all the people who are there now. And last week we were kind of alone and everyone was serving us and we never had lines or anything. And so it was really wonderful. So it was a pretty fun week.
That's a huge win.
Now, my question is, because, we talk a lot about kind of the way that people present their lives on social media and influencers making everything amazing. Was everything amazing that you tried that the influencer had, or was there like differences between the two? Like what was presented in social media and what you got to experience?
Oh, that's the reason she likes this influencer so well. This influencer is exactly who she is, right? She's older. She's over 50, and her whole shtick is like living over 50, not pretending to be something that you're not. And so to some degree, as we re-experienced some of her, like she went, I'm going to go shopping at this place, and and as we shopped there, we felt very joyful. It was clear that there's nothing on her channel that's really manufactured. She's just being herself, and we enjoyed walking in her footsteps.
See, isn't that amazing? Social media can be good, right?
Yep.
That's what it's about, though, being yourselves. I am this giggly a lot of the times. Sean can attest for that. It's not fake, unfortunately.
I think that's a fortunate thing.
I know. Thank you. So
All
you
right,
have
Kelly.
a win, Sean? Oh, me?
Yeah, go for it.
I have a really crazy cool win. So I helped out one of my admins last week. Called me and said, "Hey, what do you guys do for your Zoom's transcripts? I've got to clean this transcript up." And I was like, "Well, we can get it through something in Python. Why don't we try that?" I know Sean used something like assembly, and Bob Belderos told me he uses assembly too. And the transcript was already written from the Zoom. He just wanted to clean up. Well, assembly also has a little bit of code that has a little bit of regex, rejects, whatever you want to call it. I like rejects, but it's not rejects. Regex. And I cleaned it up and I sat there and he's like, "How long will this take?" I looked at him and I said, "Please, it's Python. It's done." And he went, "What?" And it was the best moment because he was trying to put 75 pages of transcript into ChatGPT and ask it to clean. And I said, "Please tell me you took your names out of those 75 pages and all that other stuff." He's like, "Yeah." But he kept hitting the wall because he couldn't upload it anyways because it was too big of a token size. But it was so much fun. I did like 6 transcripts in literally 3 minutes. And that was just changing the replacements of a couple of characters to find it. It was really fun to impress him and show him what we do. And so that was a huge win, like big.
I like it.
Yeah.
I mean, and honestly, that's the thing that I've loved about coming to Python is that it's really practical, right? Like you can use it to get real work done.
Yeah. Well, I never had to do anything like that, but I'm glad he did. And it made me learn about Assembly AI, which is a very cool library. So
Nice.
Cool.
Nice.
And you?
Well, my win this week was that I was left to my own devices for 72 hours. So my children are off at sleepaway camp and my wife had a business trip. So it was me and the dog for like the weekend. And it was, by the end of it, I didn't know what I was doing, right? Like I was like, I feel like I should be doing more. And I had watched all the TV I wanted to watch. I had cleaned the house 3 times, like I had done all these things. And honestly, I finally just had to force myself to just sit and do nothing for a bit. And that was absolutely a win, to just have a moment of quiet and peace, to be able to think about what's next.
That's very cool. I love those moments. Sometimes I go around a little stir crazy and I pick up the books and figure out what I'm going to read. But yeah, just sitting alone is heaven.
I agree that one of the things that was nice about our vacation is we had no plan. We literally had no plan. Each morning, we're like, what are we going to do? Which was, instead of like having a plan and a schedule and all those things, it's really nice to just be unstructured.
Yeah,
absolutely. And it helps your brain too.
Yeah,
definitely. Talking about brain, should we talk about learning?
Yeah, let's talk about learning. Kelly, why don't you introduce our guest?
So this is Dr. Chuck, Dr. Charles Severance, and I've met him virtually long time ago now. Literally like 2 years ago, watching his course. When I was taking my data science boot camp, they had listed out for people who didn't know Python to watch Dr. Chuck. And I was like, listen, I know Python. I'm just going to see what it says. And then I literally sat there the whole course because you were so engaging in the course and got couple little tricks to use in the classroom on how you taught a few things, because I love metaphors and things that help to stick. And it is just one of those things. So anyways, Dr. Chuck, he's computer science educator, leader in online learning. You have a PhD in computer science and engineering from University of Michigan.
Michigan State University.
Michigan State University.
Worked at the University of Michigan.
There you go. I messed that up. And he's probably the best known for,
and he's got the tattoo to prove it.
Oh, there it is.
University tattoo, which is where I got all my degrees, and the University of Michigan tattoo, which is where I work.
Didn't want to leave Michigan. No, please interrupt anytime. But his popular MOOC is Python for Everybody. What else did I miss? And he likes race cars.
It's a project. And invented learning tools interoperability, which is the leading standard for connecting learning systems together.
Oh, wow. Very cool. It's been a great pleasure. And then we've met you also at the Python Education Summit. And it's so amazing watching you when you walk into the room and you say, the Dr. Chuck, and they're like, that's Dr. Chuck. You're famous.
Small famous.
I always like to say we're nerd famous, but it's like a badge that I hold dearly. So welcome to the show.
It's good to be here. Looking forward to it.
Thank you. So, Sean, do you want to start? Tons of questions.
Well, I wanted to start with this quote from Jay Miller in the chat. And he just said, if no one said it, thank you, Dr. Chuck, for the work that you've done. I owe my early days of Python to your videos several years ago. And Jay is, a good friend of the show. He's not the first person to say this to us, right? Mm-hmm. Like there are many people who, in one way or another, find their way to your courses on Coursera and other places where you teach and publish. It seems like that's a common thread for a lot of people who are learning Python, that they somehow find their way to Dr. Chuck and you teach them. My question is, how did that start? Like, how did that phenomenon of being that gateway for so many Python learners really start? Like, was that something that was at the very beginning when you published your courses, or was it something that emerged over time?
That's a great question. And the TLDR answer is I did not plan it. Right? There was no plan. I was teaching at the University of Michigan, still do. and I was teaching Python to librarians and in a master's program. And we knew that these students who are going to be librarians need to know something about technology. And so I was that one course that when they show up on campus, they're like, oh no, they're forcing me to take a programming class. And these are grown-ups, they're in their 20s and they're, even older. And some were practicing, librarians and had degrees from great places. And you don't just walk in and tell them how stupid they are. That just doesn't work, to tell people how stupid they are. So from 2008 through 2012 was crafting a Python course to appeal to librarians. And these are mostly women, mostly in their mid-20s, and many of whom had a programming class, and it had gone very badly for them. So as I crafted what I was saying and how I said it and how much material I put in the class, I was using them as a focus group to tell me what the course should be. And then when Coursera came around, I just took this piece of work that I'd been building, and I'm like, oh, I'll just see what happens. And I mean, Kelly kind of mentioned it earlier. It's kind of how you teach. It's not just what you teach. And so I taught from the beginning as a kind of pull you in kind of a teaching thing. Like, I'm not smarter than you are. I'm trying to give you every metaphor, again, a Kelly word. I'll give you every metaphor, every simple explanation. And I keep telling you that it's okay, that if this is a little confusing right now, it's going to be okay. And I think that a lot of computer science teachers really enjoy and thrive on confusing the students and then feeling superior. I mean, that's easy. That's easy. That's like, I don't know if either of you are runners, but if you are a runner and we went out running, you could go faster than me, right? I mean, that's just easy. I'm not a runner. And so I didn't want to show how smart I was. I wanted my craft to be how I could teach anybody. And so that was it. And so it just so happened. Again, there was no plan. But in 2012, Python was emerging as an important language. And what's interesting is less about the 18-year-olds or even 16-year-olds that needed to learn Python in the beginning. There was a whole bunch of people in the field who were practicing, and they were pretty smart people, and they knew C or Java or Scala or whatever was there in 2012. And all of a sudden they started hearing in the market Python. And Coursera came out, there was a lot of whatever. And so people found their way to me and they stayed. And then they told other people. And so to some degree, it was like I was the Numa guy for Python. I was the right viral class at the right moment in 2012, 2013. And so that viralness keeps people coming to me. Excuse me. And so that viralness keeps people coming to me, and that's the source of the success. It's the right course, right time. The market was at the right time. You couldn't do it again. You wouldn't do it again. The market's not there anymore. The world can learn Python from thousands of places, and they can and do. So that's how we got here.
But I think there's so much more, and I think you're being a little bit what's the word where you're not showing off, because I mean, let's be honest here. How many people have taken your course?
3 million.
Exactly. Okay. And two things that you said to me at PyCon that has really stuck in my head. You introduced yourself as the kindergartner teacher of Python.
Yes.
Which I love. Hard on that, because I always joke around. I'm the best basics Python. I can teach basic concepts to anyone, person as well. So kudos to that. But you also said something about how you're making a course and it takes very long to make. You said also, like, you used your cohort, people in mind, to make it. There's something else. There's some other magic happening. And have you heard people say things about what that magic is? I mean, I know what the magic is. I don't want to tell you, but I'm just kidding. It's you. No. Have you heard other things that really keeps the people coming?
Well, I've been waiting for the Netflix for education my whole life. And that's because I really want to be a television personality, not a professor. Mm-hmm. And so I I am preparing my teaching as if it is a Netflix special, which means that I think of producing. I think of the idea of like, you know, the Beatles go into the studio and they start singing a song and there's a producer in the back. And the producer says, let's do that again, but I want you to emphasize this and this and that particular thing. And so I also play the role of producer in my own shows. There you go. That's a Freudian slip. In my own courses, I am producing myself, and I am looking continuously critically at everything that I'm going to do. And I want it to be entertainment. I really want this to be entertaining. And, you know, I put things in there. I put my office hours in there. All of those things are designed to make a connection, because I think that you can't teach if you can't make a connection. And so all these people that just go PowerPoint, 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 or tutorial, 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 they're not making any connection, because the connection is when it gets a little hard. Mm-hmm. Then the connection is what helps the student get through the hard part, right? When they believe that a teacher will help them through it because the teacher has shown that they're going to help them through it. And so there's a connection that's going on in my mind. And but then the other thing that takes me so long to build a course, and I hate to use this word, but I will, is gamification. Because I think people who think about gamification and like as their main thought, they go too far. But gamification to me is the idea that you can sit and try something over and over and over, and you can, you know, failure is not punished. You just keep trying, you keep, you know, experimenting, and eventually you get it. And so I wanted to make sure auto graders were, in a sense, a video game where I've given you something to pass, and by golly, you can pass it. And I don't make them too hard. Like, video games need to be winnable. You can't say that most of the people lose video games or they'll lose interest. And so the key thing is get people in that proximal zone of learning while they're playing this game to the point where they'll repeat it often enough, and then they break through, and then the endorphins just flow over them. And so, yes, there's design to it. And yes, every autograder, every inch of every autograder, every word, the sequence of assignments, I produce that.
So that's what I find. And I think I take a lot of Coursera courses. I was Googling somewhere, I was trying to find the list, but there were the top 5 Coursera courses, and 3 of the 5 I took: Python for Everybody, Learning How to Learn with Barbara Oakley, and the Science of Well-Being with Lori Santos. And out of all of those, I keep thinking of what those all have in common. And I think this is really important for teachers. You know, the metaphors, the humor, the connections. You can text Barbara Oakley, and she'll email you right back, even though she's probably got just as many, as followers, maybe not as
way more. Barbara,
way more.
Oh, way more.
Way more,
and way more. Yes.
Well, kindred spirits, you two are.
Absolutely.
And I think this is a really important thing for teachers who maybe don't take these courses, that you can learn a lot, and that's something special. So I'm going to summarize really quick. I love that, making connections, because if you don't have any connections with a student, whether in a MOOC or online, they're not going to follow you. Making yourself available, letting them keep trying, keep experiment, and that proximal level of learning, knowing when it's too hard or too easy. Did anything else? Another, maybe number 5. I'll keep pushing because they're all great tips.
Well, Barbara and I know each other, and we've hung out together, and we really wanted to build a course together, and we're both too busy to find the time. And both of us are crafts. We craft our work. And so it's kind of like 2 people have to slow their lives down for 2 to 3 years so that Barbara and I can make a course. And so we never made a course. We wanted to talk about the cognitive concepts of learning how to program, right? Which would be a terrific course with Barbara and I, but we're both too busy on our own arcs. But there is a piece of Barbara's course, and I took some of Barbara's course, and I think about it almost every single day because of the metaphor. And the thing that I took away, and Kelly, will see if you think of it, remember this part, and that was how important sleep is to your brain. right?
Yeah.
And no, it's got to be 6 or 7 years ago, but I can still remember Barbara explaining stuff builds up in your brain during the day, and you got to sleep, and you got to drink water when you go to sleep, because that's what cleans your brain out at the end of every day. And like, I drink a lot of water every night because of Barbara. So every single day I learned something that Barbara taught me every single day. And it was a very quick thing. And she described it wonderfully. And of course she has the credibility, so that I'm going to like, oh yeah, Barbara, that seems like a really good idea. So I'll drink more water now.
That's cool. And in what other languages? I know you know C.
Yep.
And you have a really neat kind of course that's coming out of the connections with C and Python, or I think, is that what you were saying?
Yes, it's already out. And so so I really have two acts when it comes to my online learning. And the one thing that's most important about all my teaching up to the C class was that nothing has a prerequisite, right? You're not going through a degree. And if I tell you got to take these 4 courses, you're just not going to get there. And so I made it, every course I ever taught should be starting from no prerequisite. You don't need calculus, you don't need algebra, you don't need 5 years of programming, you don't need anything. You're starting from 0. And so I have 4 courses that are like that. No, 5. And I kind of came to an epiphany, and that is that you can't just be the kindergarten teacher forever on all topics, right? And so many people would ask me how to get employed. And I'm like, look, I'm the kindergarten teacher. I gave you the things so that you can learn how to be employed. And I kind of realized that was a good first step, but it was not the only step. That I needed to come up with a pattern that says, look, if 3 million aren't going to do it, right? 3 million are not going to take my whole series of courses. But if 100 people a month graduate from a series of courses, it's kind of like a degree in programming. Then I can get them jobs. I can provide a sequence of courses that lead to employment. And so I thought to myself, and this is the concept that I call the master programmer. It's not computer science. The master programmer is the skills needed to just be a great programmer, to wield programming like a sword. Hey, let's see if my sword works.
Sean probably has one too of those. Where's your at, Sean? Wait, hold on. I don't have a lightsaber. Sorry, you
guys. There you go.
Let's see here. Hold on.
Your battery's dead, Sean, right?
No, I think I just have it switched off. Maybe. There we go.
Oh, okay, John knows how to turn it on. I don't. Oh, there we go.
This got a whole new level of weird.
You're welcome.
Now I got to turn it. Okay.
I only have
By the way,
hippos. That's all I have.
What?
Mine runs Python.
Not surprisingly, I'm just a kindergarten teacher.
But that's the thing, is like someone could go and go from kindergarten level to this. It's not that much further.
That's what you enjoy, right? That application, right. Just like what Kelly said earlier, that application brings you joy, and it did. And that's the key, is that as long as joy is with you, you're going to continue. But I wanted to make it so that what is it that a great programmer needs to be able to wield programming like a lightsaber? Because the best programmers I know almost never have a computer science degree. And yet they are Jedi wizards that know the force of programming and can use a lightsaber well. And so I said to myself, okay, I don't think computer scientists are a special breed, but I'm not going to hire them. I'm not going to work with them. They're just weird. And I want to create students that I want to hire. And that is, people that know lots of different things, but they know programming really well. And so I asked myself, what in my background and what in all those other people's background that I have so much respect for and work with and love, what is it that makes them strong? And that's where C came up. And that is, the best programmers know how computers work. so that when you're using the AI library, you may not have written the AI library, but you understand what's in it, and you understand how the library works, and then it works and it gets on a CPU and a . And so the key thing is, if you don't understand the nature of computation truly, and the nature of electronic computers, you can't be a wizard. And so I set myself out to come up with a series of courses that in the shortest possible time would create job-ready programmers. And so the sequence there is Python for everybody, C programming for everybody, hardware for everybody, JavaScript for everybody. Well, they're not really everybody anymore. And then Java. And it turns out that I didn't know I keep changing what courses they are. But the thing that I realized ultimately, that not only is understanding the full stack of abstraction is important to be a great programmer, but understanding object orientation. Object orientation is one of those things that we teach universally poorly. And every college professor teaches it the same way, and they teach it horribly, and they do more to confuse the students. And the reason is they give themselves 1 week to teach object orientation. And what they do is they teach the syntax of object orientation. I have object orientation in Python for everybody, but nobody knows it. And it just turns out that to be good with object orientation, you have to have lived it. You have to understand it. You have to see it from lots of different perspectives. And so this sequence of courses is really going to explore object orientation, plus hardware and all compilers and all those kind of things that make it so when someone says interpreter or compiler, you have some understanding of what that means. So that's the idea. But the idea is to produce graduates that are ready to be employed.
One of the things that I remember from the computer science courses that I took was that I really struggled with going from that kind of abstract theoretical presentation of some concept, right, to the practical application, right? For me, it was, I still remember learning about recursion, but it was all taught on paper and in a concepts of modern math class. It was really hard. And I never really felt like I understood it until the first time that I was writing recursive functions and actually experimenting with it and not having a base case and watching it just infinitely, loop without, or hit the end of the call stack. Right. So my question is, was the key really being able to turn that into something where you're taking people that are not being taught the abstract theoretical on paper and starting with okay, let me quickly show you the relationship between the concept and the application, because they were coming from that kind of hands-on gamified, let me work with the code and work with the concept at the same time? Or was it some other secret method of getting that connection together?
Well, you mentioned recursion. Recursion is a burning subject that if you read my textbook, Python for Everybody, and you look up recursion in the index, there's only one reference. And it's the reference in the preface that says this book will never mention recursion, which of course is recursive.
Right.
And so for me, I equally hated when I was taught recursion. It just felt like it was a detour at the wrong time. Whatever class you're taking, and there's a computer science curriculum that says week 7 is supposed to talk about recursion. It's called CS1, and it's really a terrible, terrible curriculum, but a lot of people love it and believe in it. So what can we do? You can't fix stupid. And so for me, I've always said I will only teach recursion the moment that I have an application that requires recursion. And I'll bet that recursion kind of came alive. Recursion's great, by the way. That's not a bad thing. It's how we teach it, how it's taught in computer science. I was teaching a Java class to people who kind of taken their second class, and we were parsing XML. And we were going to print out all the nodes in an XML tree. Guess what? You can't do that without recursion. You just can't. But then when you do it recursion, the base case is obvious, right? I mean, you might write a little bug and it might go off, like you said, into the weeds for a while, right, but eventually you'll get your base case right. And, you put some print statements in that says, I'm 4 deep, and now I'm 5 deep, and now I'm 4 deep, 3 deep, whatever. But ultimately, chasing down trees is a recursive activity. And so if you don't know recursion and you imagine trying to parse a hierarchical document like XML, but nothing but for loops. And I turned out I did this in my freshman year in college. They were going to have me parse mathematical expressions with parentheses and nested parentheses and all this stuff. And they gave us this recursive algorithm. Excuse me. And I said to myself, I am so smart that I don't need to use recursion here. I will figure this out because I can write a for loop to see a parenthesis and look up to the next parenthesis. And if I see another parenthesis, then I'll just add one and I'll make sure and I'll do all these things and I'll scan back and forth. And this was in cards. And by the time it was done, most students had a card deck that was this thick and they were finished with the assignment. I never finished the assignment and my card deck was 2 feet. And they would give me, I would get through one piece of input, then I'd try the second one and break, and the third one and whatever. Because the learning there for me was a tremendous bit of learning where this is where you use recursion, Chuck. Don't fight recursion when it's the right solution, but don't teach it in week 7 of a first programming class.
But I think that's like number 6 of the teacher rules. And this is why I love this conversation so much more than just the talking about Python. It's the fact that we do things because we have to. We teach concepts in math because we're supposed to, but it's not practical. It doesn't make sense, and it's forced. And when it's not practical and it doesn't make sense and it's forced, of course the kids trying to learn it, whether they're 16, 17, 18 or 10, are not going to learn it well. I mean, and some might, they'll memorize it and they'll be able to tell you what recursion is. They can give you the definition and they can explain it exactly the way the teacher has, but the practicality of using something goes away. And I think
there's no retention.
There's no retention.
There's no retention.
And as Barbara would say, there was no connections from the short term to the long term and the myelin wrapping around the neurons, something to that effect.
Well, and it's interesting, but Pamela Fox is chiming in also and saying like XML parsing. I'll put her on the screen here. She says XML parsing is great for recursion tree-based data structures. She's got some extra comments in there about UC Berkeley and the way we should try to teach things. And I think it really does reinforce this idea that when you have the right problem and you have the opportunity to teach the right solution to it, then all of these things fit together and it just makes sense. Like, okay, perfect. But again, trying to force it or trying to get it to be something that you have to learn because everyone should know it, right, doesn't seem to make a lot of sense.
The problem that Kelly is talking about and that you're talking about, and now Pamela is also talking about, is the problem of curriculum. And so curriculum exercises are, here's these 75 things that we want you to know before you're done. And wouldn't it be nice if instead of wasting 3 grades to learn these 75 things, we could do it in 2 grades? And so then what you do is you just divide up to 75 things and 3 days on this and 2 days on that and whatever. And then you're like, I'm a master of efficiency in that I took something that took 3 years to learn. And now you're going to learn it in 2 years because of my brilliant curriculum, which is nothing more than taking each amount of time and multiplying by 2/3.
Right.
Yep.
Right. And what I think this is bringing it back to the beginning of where you started. What I also like is that the way that you designed your course and the roots of where it came from was not based on an outcome where I have these 75 things and at the end of it, all 75 boxes will be checked. You went to it and said, I have librarians that need to know something that will be valuable to them, right? And so instead of going from 75 things to now how do I cram that into the schedule, you went and said, I have 75 librarians. What am I going to teach them that will be practical and useful for them to be able to use in the rest of their professional lives, right?
What will they learn and what will they retain, right? I'm going and cut, right? Just take stuff out until they understand it.
Yeah, that's like the biggest things whenever working with teachers What are the 3 big takeaways? What are they going to remember you for? What are the 3 things that they're going to remember and be able to state 5 years from now, 10 years from now, 20 years from now? And that's huge. That's huge. And that, I think that to me definitely sums up why you have 3 million people. And funny quick story. I play adult kickball. Tonight was supposed to be a game, and I said, I'm not going to come. I have a podcast. I'm a little bit of nerd famous. They're like, oh yeah. And I was like, yeah, invite some people on. And I'm having a really important person on the show tonight, so I'm not going to miss it. And there's like, well, who's the important person? I was like, Dr. Chuck. Well, Dr. Chuck? 2 people on my team. Granted, they're also programmers, but that's just what a big impression that you've had on people. So I do believe it has all those tricks of the trade to be a good teacher.
Here's another interesting observation. And the other interesting observation is slow is not always the answer. Mm. And so what I did was I cut out difficult concepts, but I didn't cut the important concepts out. So by the time I was done, if you look, I was looking for a copy of my book somewhere. Okay, here's my book. This is the Greek translation, so I can't find an English translation of it handy in my office. If you look at the book, there's chapters 1 through 10. And you literally can take chapters 1 through 10 and stop. I reduced it so much that I could do chapters 1 through 10 with people who were anti-programming and get them at a mastery level in 5 weeks. So 5 weeks of a 15-week class, they learned Python. Mm-hmm. And the midterm exam was to write code. So we go from 5 weeks. So having a sense of pace and a sense of like, you can't fall behind. Let's go, 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 go. But then I've laid out a achievable thing. Then that gives them a certain amount of energy. And by giving them this high stakes, terrifying midterm exam where they got to write code in 2 hours. And at the beginning, they find that the most terrifying thing in the world, but it's also a motivating thing. And of course, they all did great. And the sense of endorphins that come from crushing that midterm exam that terrified you for 5 weeks. And then the second half of the book is not about Python. It's about applying Python. So XML, JSON, scraping, right? Just application. So I got that so tight that in 5 weeks, I could get through 10 chapters and literally you could stop there. But then what I could do is take the next 6 or 7 weeks and apply it to the point where now they're operating at another level, which means Python is a skill that they now have. So the second half of the class is applications. It's not like, okay, I'm going to teach you lambdas. Now I'm going to teach you this, and I'm going to teach you how to use Jupyter Notebook, and I'm going to teach you how to use pandas and NumPy. No. We're going to celebrate the achievement that you've done in the first 5 weeks of this course, and you're going to use those skills for the next 5 weeks of the course. And again, all about retention, and making those in-the-mind connections so that years later, they're not afraid.
Yep. And that's why I teach 6th grade and 8th grade. I do. I don't get a lot of weeks, but go ahead, Sean.
I was going to ask it. I mean, to what extent has, I guess a couple of things. To what extent has teaching adult learners informed the way that you think about what you're teaching? And would it be different if you were teaching K through 12, right? And then the second question is, how do you think that has created kind of also a ripple effect where maybe you intended it towards adult learners, but many other kinds of learners have been able to also learn effectively from what you've made?
So I've always aimed all of my courses at, let's just say, 13 or 14-year-olds, right? In terms of the intellectual development, right? No calculus, just 13-year-old ninth graders. When I'm building a class, I'm seeing 13-year-old ninth graders is who I'm looking at, right? Now, the problem is I don't get to teach ninth graders because the horrible nature of our K-12 system. And so to me, when I'm teaching 24-year-old adults, they're a proxy for a ninth grader. With one wonderful difference, they will talk back to me, right? They will not put me on a pedestal. They will knock me down. I have to sit in office hours, and they come walking in and like, I don't get it. I don't get it. I don't get it. And I'm like, did I make a mistake somewhere? Right. And so these classes have always been aimed at high schools. And so I actually have a whole high school curriculum that I built that starts in 9th grade, maybe 8th grade for advanced kids, and goes all the way through 12th grade, with the idea that at the end of 12th grade, people could get a $40,000 to $50,000 programming job at the end of 12th grade. Now, will I ever see that day? Will I ever see a situation where we're graduating job-ready high school students? Or if they want to go to college, they come with a master programmer skill set, and whatever they want to do, be it biology or economics or whatever, they're skilled at everything, or AI for that matter, right? And so I have been thinking about that from the very beginning, that this is not about adults. And it turns out that thinking about a high school student, a 9th grade student, is a way for me to not just say, oh, they'll figure it out. This is grad school. You should be tough by now. No, grad school is just as tough as 9th grade. And we pretend that somehow grad students are like superheroes and they're all strengthed up and all that stuff. And so I aimed this at high school students from the beginning, and knowing full well that I will never get that chance, right? The curriculum will never let something stupid like chemistry or physics move out of it because it's in their list of 12,000 things they want to teach badly. And they won't give me, 4 to 5 half-year semesters to teach technology. But
I hear you, and I've been working. I have 9 weeks, 9 weeks, and 9 weeks, and so we get it done. I'll keep the fight for you, Dr. Chuck. I have faith.
27 weeks is better than 0 weeks.
27 weeks is better than 0 weeks, and we start with 10-year-olds. So now you can change your profile, keep it down to 10 because they can do it.
Well, I'm not going to teach Scratch, and I'll let someone.
I teach Python. I teach Python to 10th graders.
Maybe my 9th grade. Yeah, okay. 10th grade. 10-year-old.
10-year-olds.
Okay, yeah.
So they can do it. They're getting smarter.
No, I think they are. But hang on. Before we leave this topic, the reason that I want to just find the curriculum people in high school and just choke them for like an hour and shake them is that I believe that developmentally, and you're a real teacher, I'm just a college teacher. I think developmentally, the ages of 13 through 18 are the most absorbed, the ideal time to absorb complex concepts. Mm-hmm. And so if we wait to teach these essential things for 21st and 22nd century skills, and we wait until they're 21 years old, we're idiots.
Yeah.
Right? We are teaching them completely stupid stuff like chemistry and physics. I'm not saying there shouldn't be a chemistry for everybody class, but when I went to high school, the chemistry class was actually pretty serious. And the physics class was even more serious because I was like a nerd in high school, and I don't retain anything from any of those classes, nothing. And my brain was so ready to absorb something I could understand. And so that's the double tragedy of not allowing K-12 to teach this stuff, is that we are taking young minds that are way better at learning new things than old minds, and we are exposing them to absolute rubbish.
I've had similar thoughts over the years, and I would say I think there's a couple facts that we're failing to, or truths even, that we're failing to recognize. So much of that K through 12 education curriculum was built around a time where the only way that someone could learn was either from a book or from the sage on the stage in front of the room. Right? So what are we going to teach them? We're going to teach them the things that everyone should know, and that we have a steady supply of teachers who can stand in front of the room and teach it badly or sometimes decently, right? But we know that, and that's fixed. That's what we have available to us, right? Like, so if you go to pretty much any high school in the country, there will be a chemistry teacher there. There will be a biology teacher there. There will be a physics teacher there, right? But we've missed this truth that we are no longer limited to who can stand in front of the room in our classroom in the middle of Iowa, right?
Let's make a way to make those teachers in the middle of Iowa, right? We got a way to teach the teachers. And I'm preaching to the crowd, to the choir here. But yeah, we got to teach the teachers. And if you look at the first lecture in Python for Everybody, I'm talking about making more teachers.
Right. Yeah. And then to further, I love the idea of the chemistry for everyone, right? What if there was, the role of the teacher in the room is not so much to be the one communicating all knowledge and truth about that subject, but they're there to facilitate the learning process for Python for everyone, for chemistry for everyone, for, and students can take the courses that make sense to them, that fit with what they're interested in, what they're good at, and what they ultimately may want to do in the future.
So we mentioned chemistry kind of on purpose. So here's the funny thing, right? Chemistry is taught really badly in high school, but in at least 50% of the places in college, it's taught really well. And that's because the chemistry department understands that not everyone is going to be a chemistry major. And so they create a course called Chemistry for Non-Majors. And what are the founding principles of chemistry for non-majors? We got them for 15 weeks. Let's entertain them. Let's reduce the scope of what we're trying to teach to that which they can absorb, so that they still understand that when you're charging a battery and there's hydrogen and oxygen coming out, and then you start a fire and the oxygen and hydrogen go back together, you at least kind of understand that stuff, right? That's useful. So with earth sciences, right? And so the key thing is if you observe the chemistry teaching field, there is whole conferences in chemistry about how to teach one class, the chemistry for non-majors class. But high school should do that. So chemistry has chemistry for everybody already. It's just widely distributed. Now, there's a bunch of people that go to conferences for computer science for everybody, but in those conferences, they presuppose that everyone wants to be a computer science major, because it's hard for computer scientists to conceive of the notion that not everybody wants to be a computer science major. So they create courses that are recruiting courses, but then they do them badly. They're trying to capture everybody to come to computer science. And so that's why the first computer science classes and the redo of every first computer science class is literally a disaster, because they're trying to trick you into taking computer science.
Right. Or they're trying to filter, right? Which is worse, because if you're not good at this class, then you're not good at coding at all, ever, right? Or that there's no value to this for you.
You're a business major. God created a business major when you were born.
Right. And, it's our privilege to teach this to you, right? That you should now know that you are not ever going to be a coder or a computer scientist.
I feel so good. We're not wasting anybody's time because of your lack of talent.
Right.
You guys are so bad. I am going to derail this conversation, but instead of making them computer science, I'm going to tell them we're making them programmers. And I think that's one thing that Sean and I really took into heart when we were designing our curriculum. Was we're not telling you to go be a developer. We're not telling you to go take CS in college. But what we're telling you is this is some really cool thing right here, and look what it can do. I can remember Sean. That's why Sean has a Python coded lightsaber, and we had hand sanitizer hooked up to the Alexa, to a Pixel board, to the monitor, to whatever else he hooked it up to.
We had stats running. I had a dashboard with visualization of how many times and what time of day people use the hand sanitizer dispenser, right?
And me, like Jay, I would always pull in the graphs, because I think graphs are cool. I think Jay said that in the episode we had, just graphs and being able to get some data, how many push-ups did all the boys do in class, and we get to graph it with Python in 10 lines. So I think that sums it up with the whole point is, if we try to only make Python for computer scientists, we really leave out the whole diversity of what Python and what programmers can be. And I think that's really important. I think a lot of the people that have come on our show as well, we want people to code because coding can be fun, coding can be useful, and coding's practical. So Python should be for everybody.
Let me pivot your pivot. Okay. So let's imagine that the way the three of us want the world to looks this way. And we're teaching high school, we're teaching good programmers that are enjoying technology and making things and making graphs. And they come out of high school knowing Python, they know database, they know C, they know JavaScript, they know web development, they know Java, they know object-oriented programming, and they're 18 years old. Imagine now if you're a computer science department. Imagine those 18-year-olds are walking into a computer science department. Imagine how much better computer science would be.
Mm-hmm.
If the people walking into computer science already knew how to program.
Well, and I'll do you one better. Imagine if those same people, maybe it's the same skill set, maybe it's different. Imagine if they walk into a chemistry department or a biology department or an English department or social sciences. And they've got all these skills and capabilities that then they marry with their passions for what they really care about. Right. And I really don't want to say, like, I don't want this to sound like I'm, denigrating computer science, because if there's room for someone to go into biology with coding and do really well at it and marry their passions to it, there's absolutely room for someone to go into computer science and be an amazing computer scientist and get really deep into all of the weeds of, computational approaches to solving problems and finding new ways to do the next big thing. Right. There's the thing that I love about what you've done and what you've pulled together is that you have made it okay, right? The same way that you made it okay for the librarians, that you're going to be okay. You made it okay for everyone to learn programming and make that part of who they are, make it another skill for them instead of something that makes them feel bad about themselves, right? About how they're not smart enough.
Yeah, I have to do Jay's comment. This is really interesting because he says something I don't think has been touched on is we're talking primarily about the hireability of these folks right out of K-12. That's an interesting point. Like maybe they don't have to go to college. Where are we going to be? And poor Sean said it was 7:00. We're pushing our
a little
shifting.
over, but it's worth it.
It's worth it. It's an interesting topic, and I know I talk a lot too.
I have a short answer for this.
Okay, go ahead. Better than my long answer. Go ahead.
No. You were a guy pointing out the question. What if sometimes when you achieve something, you're like, oh, wait a sec, now I caught the car, right? The dog catches the car eventually and doesn't know what to do. Think about it this way. What they do is they go to college doing, as Sean said, anything they want. And instead of working at a coffee shop, they write software. They don't have to go work and not go to college. They can work their way through college on a $40,000 a year software developer salary, junior software developer salary. They still need to go to college.
Or they can be like a couple of the AI eds. They go through college until they make something that actually sticks.
Yeah.
And then they quit halfway through. But it's sky's the limit, whatever.
If they change their major, they can still do programming. If they, on and on. And want to take a gap year, they can make money programming. If they, whatever it is, right? And so I think that the patterns can be much more flexible once we have high school graduates with these kind of skill sets.
And here's, great follow-on point from Jay too. Like, what about the places that don't have high schools, right? That don't have colleges? This information's available there too, right? Like, people are smart all over the world. They're capable of learning these things if they have access to the information, right? We're talking a lot about high school and college because, that's what we know really well. But I think, Jay's talking about, especially even within our own country, there's plenty of places where there's not a lot of access to good teaching and good educational resources. In other countries, there's not the same access, right? But we could make this available. This could be something that anyone can use, and people can get jobs, find validation, find purpose, right? regardless of where they live, because now as long as they have access to the information, they can do it.
Yeah. And just a point, not that I wasn't catching Pamela Fox, she was commenting as well. I was trying to listen and type. She's following us on LinkedIn, so she's put some really good comments, and an HT webpage about the data. She says not perfect data, correlation causation of optimal age for teaching text coding. So that's going to be on LinkedIn.
I'd like to see that, because I have an instinct, but and so it'd be good to see some data about the optimal age to teach it. So
we'll have to have her explain that when she comes on our show in 2 weeks. So, and I know you guys know each other, so which is really cool.
Yep.
And we'll get to follow up on that conversation later.
Right.
So,
well, I know I'm way over time. This was way too much fun, and I think we should do more of this. There's so much good discussion, good conversation. Dr. Chuck, of course, people can find your course on Coursera, right? They can find your books. You have office hours for people who are taking your course. What else should people check out that you've been particularly interested or are working on lately?
Well, I would make the following observation, and I do something very different in that I think about my courses the way a publisher. I mean, Pearson My Math Lab has been a guiding light in terms of how I build my material. And so my material is always integratable into Canvas, Start-Learn, Blackboard, Sakai, Moodle, and so that you can treat me like my math lab. So you can teach Python and use my autograders and plug them in, and my YouTube videos and plug them into your LMS. And I think that's a cool thing in K-12. The problem is that it's really hard for a K-12 educator to get that information and then get the tiny little bit of tech support it takes to get that all to work at the time they need it. And so one of the reasons K-12 is the way it is because publishers have the money to jam solutions down K-12's throat. And I have solutions, I just don't have the money to jam it down people's throats. But that's a thing I've always wanted, to scale this. And then I know we're going to run out of time, but Jay, your question, my question are the same, and that is, it's not just about America, and it's not just about kids that are going to go to Yale. It's got to be everybody, everywhere. And I won't go into the hour that I could talk about that, but the essence of it is scalable, distributed, remote internships that are paid. And I know I can make it happen. The one thing I can't do is pay for it, right? And so I'm just following the crusade, Jay, that you're following. I'm going down that path, and I just hope that by the time I get there and that I've done all the pre-steps, that somehow money will appear where I can hire the graduates of the internationally remote and then put them in working teams, an internship, right? And then from that, get their job, because you can't just teach people and say, go to get a job. You got to have this hybrid moment in their life where they're working on an internship. And I want that to scale worldwide, internationally, independent of economic situation.
I like it. I think that would be very uplifting to a lot of people.
Right? Yes. And I want to use the fame, the nerd fame I have to sort of advocate for that. Even if it won't make me any money, I don't care.
It's very honorable, and I'm like reading. I can't stop reading the chat. I'm going to turn this thing off. No, I'm just kidding, Jay. So Jay's comments are on YouTube, Pamela's are on LinkedIn, and they have been great active participants in this chat. Sean needs to be doing a better job at it.
I'm feeling panel discussion is coming. Like I think that's our next step.
That's a good idea. That would be so fun. Yeah,
that would be. We'll have to get through the summer, because I have some really great talks all this summer. So I'm excited. Excited. So Sean, it's 7:17.
All right, let's wrap it up. Dr. Chuck, thank you so much for joining us. This has been an absolute pleasure to speak with you tonight and just have a really good conversation. So thank you for joining us and being a part of this.
Thank you so much.
All right. Well, then we'll wrap up quickly. No announcements this week. Just stay
No
tuned for more.
announcements.
No, we have so many upcoming guests. Like, let's keep it going. Keep it a surprise.
Just one.
Just one. You want to do one? Okay, you can do
next
one.
week. Next week, Jay, hold on to your seat there. Kelsey Hightower is going to be on the show next week, and then Pamela Fox the following week. That's it. Go ahead.
See?
Sorry,
Perfect. All right. All right. Well, so for Teaching Python, this is Sean.
And this is Kelly signing off.